Let me introduce you to my Warco drill press. But could it be improved?
Hello again, welcome back to episode insert number. In this episode we...
Wait, hold on, no, it's not like that.
What?
Yeah. Okay.
Yeah, but look, it says insert. So previously in episode 1 we have a look at the inverter and we got the motor wired up. Then in episode 2 we made up the control box and we had a look at the inverter parameters. Episode 3 we fitted out the electrical cabinet and we had a look at the control systems and got it running off the external control. And in this episode we're going to finish kitting out the electrical cabinet, we'll get the switches fitted to the control box and we'll start stripping down the drill press into its basic components. Welcome to episode 4.
So if you remember back to the previous video, what we didn't quite finish off was what to do about this module here. So there's a spare unused connection on the inverter that goes live once the unit's on, and it currently runs, or one of them runs the fan that's on the bottom here, the other one is spare. Now I've wired that up so it comes out here, and what I want to try and do is to use that 12 volt signal when the motor runs to trip a relay and then use that relay to run a couple of fans. I don't think I'm going to be able to run them directly off here, but I don't want to chance it anyway. So the question I was asking myself is, do I need to use this 5 milliamp relay here? So it only needs about 5 milliamps to trigger, which I think would be, well, it's a very low value, so that'd easily be good enough. The problem is, it's not very easy to mount. It would need a special kind of DIN rail connection making. It's not particularly robust, so I prefer to use this one here. So the question is, how much current would that draw compared to probably what it's expecting? And I've done some maths down here, so let's bring it in a bit closer. So to try and work out what it's expecting or what might be safe, I got one of these little 40 centimeter fans. 40 centimeters. Okay, so to try and work out what might be a safe load, I got one of these 40 millimeter fans. I got a couple of these spare ones. I assume it's the same current rating as the one that's on the bottom of the inverter. So it currently runs one of these. That's a 40 milliamp draw. So I assume that the one they've already got there is rated at that, and that's kind of what it's expecting in the second unused one. And just for interest, just worked out the resistance, so notionally 300 ohms. So it's expecting to pull 40 milliamps. I then had a look at the relay I want to use. This is the 12 volt, bit more robust one that I want to use, and that pulls on my meter 80 milliamps, so 150 ohms. So it's actually pulling twice as much as this. So the question is that going to be okay? Is it going to break or damage anything? I think that's still a fairly low current draw. So the only one way to find out. Let's fire it up, switch it on, and see if it will run that, and try it a few times and see what happens. Hope I don't break it. Okay, so I'm going to switch it on, which will run the motor. I'll also put the 12 volts down this wire here, and let's see if it turns the relay on without doing anything nasty over there. So here we go, 3, 2, 1. Again. Okay, let's try one more time. So we'll switch on. Relays on. No smoke, nothing untoward. And switch off. Oh, I think we're going to run with that. Good. Okay, so I've swapped that relay module for this 8-pin DIN rail mounted version, so it's a bit more robust. I'm pretty happy with it now. So basically when that unit runs, it will send 12 volts that comes from that orange cable there
out through the white cable into these last two terminal blocks here. So this will be our switch 12 volts. So anything plugged into there that's 12 volts will run when the motor runs, and it will stop when the motor stops. So I've just wired the fan in at the back there. So let's see if that turns on when we run the main motor. So here goes. 3, 2, 1. Works. And if I feel out the back here, yeah, that's blowing air out nicely. And when we turn it off, it should run until the motors or the frequencies cool down. So we'll switch off now. Still running. And it's off. Fantastic. So we'll also use that. We'll also use the switch 12 volt to run a cable that comes out the side here, and that will go to an auxiliary fan that's going to be mounted on the back of the motor. Fantastic, it works. Okay, so there's another little unused module to add to the collection. Okay, I think that's about as far as we can get here. So we've got the control panel there, but the main cable is too long and I can't really cut that till we mount it onto the machine. The box is done. I've got an auxiliary fan to wire up, which is just pretty trivial to do, and that will go to the back of the motor. Again, we'll do that when it's on the machine, and this is really long as well, so I'll cut that to length, but again, need to do that when it's on the machine. I think that's kind of it. So for the control cabinet, we're done. Well, I think it's time to strip this thing down, so let's get started. Right, next I need to take this cover off here because the wires are trapped and some of them are screwed with little fasteners that are on the underside of this. So I need to get this off. The pulley on the end here is larger than the hole, so I need to take the pulley off, and there's a great big nut on the top there. It's about 32mm. To hold it still while I'm trying to undo that, I need to lock this off in here. So I'll just put the lock nut off there, just hold the coil at this position, and then I'm going to take the spindle out with the drift so I can get a lock in there. So if I spin the quill around now, you can see in that little gap there, you can see another slot inside there on the rotating part of the quill, and there you can just see the end of the tang. That's the arbor. It's like a double-ended tapered arbor that holds the chuck on here. So there's a short taper at this end and a longer taper here. So just going to use a drift to get that out, and then I can use this space to lock it up. Little tap and it should come out. Nice. Okay, it's been in there a few years. It looks like it's a bit dark. Looks like I could do a little bit of a clean up anyway. I'll give that a clean before it goes back together, and the taper inside there as well. Right, well the purpose of doing that is so now you can see we've got quite a large area of the slot available, so should be able to lock the inner part against the outer and stop it rotating. Okay, it's given us a lot more space now. Jam this in nicely. Okay, it's worth knowing that more often than not these are a left-handed thread, so do be careful, otherwise you'll spend a long time there getting very frustrated. Okay. Wasn't massively tight. So while we're up here, we'll give you a quick tour of what we got. So that's the pulley, we've just taken the nut off. The hole in the middle there, that was where the idler pulley went. It just dropped into that slot, there was no fixing. And then the motor, drive motor's over on that far side. Then the little red switch you can see there, that's the safety lockout, so if you open the lid it stops the motor running. I don't think we'll use that in the new installation. And then you can see there's a couple of wires I've got to get out. I'll need to remove the yellow cover to get behind there. Right, so next up we need to take the drive pulley off. It's likely to be on a very slight taper, and I don't have any bearing pullers or pulley pullers. I'm going to borrow some this weekend, but I forgot to get them, so we'll see if we can improvise and get something together and get that off. Okay, and by the power of YouTube, fast forward about 30 minutes later, I've just made this. It was a rectangular piece of section, so I just cropped it to the width. Took a piece out here, just filed these, so this rough shape that will go inside the pulley. M12 tapped in the centre there. And I'm going to try and just hook it under this top part of the pulley here. And these are metal pulleys, so with a bit of luck it will be okay, and it's slightly sprung loaded. There we go. And I've put the left-handed nut back on here, but just give myself enough so the pulley can actually lift clear. So it should be on a taper, so as soon as it's lifted a millimetre then it should be gone. And then I've just found this scrap piece here. I'll just put that under there, and that means the bolt will press onto the inner part onto there. And if this doesn't work and it just bends the arms or something else, then I just won't include this bit of footage. And that will keep you in. Actually, the fact you're watching this now means you know it worked. So the broken, oh, it's got it. Yeah, it's got it. There we are. I knew it would work. Alright, so let's get this off. As you can see, it's a left-handed thread for the nut. It's got some weight to it. Alright, so you can see the taper on there. There's a bit of a clean, that's fine. So now we can do these 4 screws and get this off and get the old electrics out. Right, so now we've got the lid off, we can get to the electronics. So they were held on here. We can undo this clip here. And this one. Try not to drop it inside. Quick tour of what we've got here. Obviously this is the spindle head, the driven end, and then here you can see this is the light, so I'm going to retain that feature, so we'll see how much cable we got on there, see if we need to splice some more on or if we can get back into the fitting. I'd like to use that again. Then you can see the cam mechanism, so this is the mechanism that adjusts the motor in and out to get the belt tension right, and you can see the way it works. You have this little cam device with a sort of finger that engages just in one of these rods in a slot, and it pushes them backwards and forwards, and that because those rods are connected to this plate here that holds the motor, you can effectively tension it. And then there are 2 lock screws that go in the side here, thumb operated lock screws that just lock it off in that position. So that's how that works. And then obviously got the motor mounted at the back on with its pulley here. Let's just have a look at the light fitting. Okay, so it's just a 2-pin connection. Oh, that's fine, in which case I'll just make a dedicated longer wire. Okay, that's fine. I'll leave that for now.
Alright, so quick recap. We removed the intermediate pulley, the idler pulley there, and then that top plate and all the wiring. So next job is to take the motor off. It's loose. Okay. This is where it gets interesting. Right, I'll just loosen the bolts on the other side and then I'll bring you back. I can't be bothered to move the camera yet again. Alright, so the only thing holding the motor on is just this one bolt here. So here we go. And it's quite heavy. You know what, I'm going to move the camera, it's in my way. Right, so I've loosened the other side, the only thing holding it on is just that one there. And it's quite heavy, so I need to catch it. Whose idea was this anyway? If I'd have thought ahead, I'd have made a kind of platform to hold this, but I didn't, so I won't. Alright. Oh, if I can just catch it on that pulley maybe. Oh yeah. Alright. There may be some swearing, hang on. Oh. Oh, you oh. You what the, that's jammed. Right. Yep. Oh. Oh, she's out. Alright. And here it is. Okay, we need the motor mounting plate. I think don't know if it's got a lock ring on it or something. basically to measure this and then make a new one for the new motor. There you can see the groove. See the groove there, that the little cam thing moves backwards and forwards, and then the flat areas there which lock it off on both sides. And there's the lever there, and the locking holes are there. That's what you've got inside. Okay, so poly's removed, all the top piece removed, motor's removed, motor mounting plate is removed. I'll take the DRO off next, just to get that out of the way. Yeah, that's where we got to. I know what you're thinking. What? What am I thinking? Well, you're thinking, let's invert the motor, mount it on top, and then cut off that back piece, the old motor mount, and then you can push the whole thing a little bit closer to the wall. But won't that invalidate the warranty? I think it's a bit late for that. Look, stop giving me ideas. Let's get this thing done. Okay, just saying. Okay, and there's the depth stop. Okay, I've decided I'm going to take the head off. I need access to the column later in the build anyway, so I want to make sure I can definitely get that on and off. I'm going to make it as light as possible therefore, so I'll take this handle off, take the depth stop guide off. While it's off, I can also take some more detailed measurements for the CAD to make sure some of the parts of design are going to fit. So let's do that now. I'll take these two bits off. The handle's just held on with a simple cap head. And it's got a little pin in it to give a positive location so it doesn't rotate. Yeah. It's held on with that little M8, and there it is. And then you can see in there it's got the pocket that it sits on onto here, and then there's just a little drive pin there. It works pretty well. This is just a split clamp style. It holds that on there. Yeah, so just got a split there and the usual, it looks like M8 I think. It's quite a nice solid piece of casting just for the depth stop. It works really well. Right, it's a little bit less weight anyway. I'll just give you another shot here of the mechanism for adjusting the motor. So if I turn it all the way around, you can see there's a pin on the end there, and that engages in a little slot in those rods that move backwards and forwards. So, oh, it's that way, here we go. Just move it and it just gives you that cam action. I was thinking about taking this out, but second thoughts, I think I'll leave it in because that spacing's rather important, just to get good engagement, so it's not going to weigh anything in it. I don't think it's really going to get in the way, so I'll leave that in. There's another shot, a little bit closer there, you can see the lamp in there. It's just a 2-pin connection there for the wire. And then the spindle, and here's the tapered drive. And then it's got an internal spline that runs on this spline, so this is the part of the quill that moves up and down, but because it's splined it always keeps that drive engaged, and that's it. Right, let's get this block off. So, right, we're finally ready to remove the block. It's just held on with these two set screws here that hold it onto the column, and then we just lift it up. And she's off. Okay, so what we got then, so there's the head that we just removed. That was the belt cover guard, the power switch, the motor. Down there's the safety lockout for the lid. Depth stop down here, the other bit of the depth stop, and that was the depth stop bracket, bulb here. The motor mounting plate was a bit slid backwards and forwards. That was the fence off the old drill press table, some fixings. They were the lock screws that held this in place, and the quill handle, pulleys, and the chuck there. That was the intermediate pulley, we didn't show that, but that takes up the slack between the other two pulleys. There we go, that's what we got. Okay, so this is the control box that's going to go on the front of the machine, and it's got a control panel like this. As you can see, I've started to put the components in. So these are modular switches, so they have, well, you can stack them up on the back here, and basically what they have is a pair of normally open on one side and a pair of normally closed contacts on the other. So when I press the switch down here, you can see that contact join across. So that's normally open, so it's not connected at all, and then we press that, then that joins that. So we got normally closed. I've added one on the bottom because I needed two normally open contacts, and on the other side, on this red side, you can see they are normally closed on both those, and when I press it, and then they become normally open. So you've got your normally closed on that side, normally open on that, and you can in theory put, well, as many of these as you like. So you can see they kind of clip on. It'll clip back to each other, but the load required to press the switch does go up quite dramatically. So I've got two on there at the moment, and I think that's going to be okay when it's actually on the machine, but I don't think I'd want to go much past 3. Also, they start to become quite long, so you can see how they just about fit in that box. But you'd end up with a rather deep box if you added any more. So that's the principle anyway. The other interesting thing about them is you can take them apart. So there's a couple of different types. This type, you press that white plastic piece in, so when you press that in, and then you can slide this out, and it comes out, and there's an aligning sort of groove there that needs to go into there. So you can then undo the nut. On this one there's a kind of a plastic washer as well. So you put that through your panel. That allows you to tighten that up, and then you simply align this groove. There it is, and it snaps back together. Then you've got your you're ready to put your contact pack on the back, whatever you want, normally open, normally closed, or whatever you're going to put on there. So that's that type. Then there's the emergency stop type. Now these are a little bit different. So the way these ones work is we can unscrew this front piece. So they load in from the front like that. And you get the idea, and that comes apart. And you can tighten that up. Now the orientation doesn't matter too much, but you probably want to put these terminals in a most favourable position for wherever your wiring is going to go. But obviously from the front they're completely round. It goes a bit like that. There's our emergency stop. And finally we come on to this type, which is a 3-position rotary switch. So we've got to the left, centre, to the right, and then we've got the terminals on the back, which are made or broken depending on where you put this. Now you can see that we've obviously got to trap the piece of panel inside there, but this is larger than this. There's no obvious way to get it off, and the way you got to remove it is remove this plastic piece here and then take the whole thing out. So if we take that out first, oh, there we go. So we had to get the screwdriver, oh, there we go. Get the screwdriver down into that point there and lever it like that, and then it comes out. Okay, we got it. So what we were doing was basically pushing these tabs out of the way. Now that's removed, we can take this off, we can feed it through the panel. Looks pretty good. That should just snap back in. So there we go. And that's back in. So now we've got forward, reverse, and off. Right, now the tricky bit, so I've got to hold it on the wall and get the first screw in. So what I've done is I've magnetised it, but also just for double measure, put a little bit of tape on just to hold it in place, because I'm going to be holding this up and then trying to get the screw in with the other hand. So here we go. Okay, pleased with that so far. I think that wraps up this video. See you in the next one. Stop giving me ideas. Okay, just saying.